In this challenge, we're building a car that could be both remotely controlled from a website and also self-driving using LiDAR, ultrasonic sensor, with PID control. There are two main parts. The first one is the Raspberry Pi, functioning as a server, hosting a website, receiving signal, and sending commands to Arduino through serial port. The other half is the Arduino. It is mainly responsible for driving control. There are two LiDAR sensors, one ultrasonic sensor, one ESC, and one servo motor connected to it. As we can see from the diagram, there are four XP on Arduino powered by power banks, serving as localization beacons. The XP on Raspberry Pi send the request to other beacons and get a response. We use the RSSI and beacon ID as our input data. Through MLKN algorithm, we know the current location. Another Wi-Fi dongle is used for wireless communication so that we can see the website wirelessly. We apply the no IP service inside the Pi so we can access the website globally. The Logitech webcam is connected to Pi through USB port, and by using service called Motion, we can have a streaming video. Also, Pi is powered by a power bank. The car control is all down inside the Arduino. It communicates with Pi through serial ports using cable. When we click a button on website, the Pi sends a message to Arduino, and Arduino will setting the flag's value accordingly. The two LiDAR connected to Arduino read the distance to the left and the right. By using the PID control, we can make the car drive in a straight line. Ultrasonic sensor is used for detecting the front distance and collision avoidance. By sending PWM signal to ESC and servo motor, we can control the speed and the direction of the car. What is going on inside the Arduino will be illustrated here. In each loop, the Arduino will firstly check if there is any message from serial port. If there is, it will read the message and set the flag's value accordingly. If not, it will skip it. After that, we check the power flag. If power off, we shut down everything. If power on, we will check the auto driving flag. If we are not in auto driving mode, we will move the car according to the manual drive flags, such as forward, backward, turn left, and turn right. If we are in the auto driving mode, we will then check the front distance. If there is something within 70 centimeters, we will stop the car. Otherwise, we check the left distance and turning flags. If left distance is larger than 3 meters and turning flag is on, the car will make a left turn. The turning flag is set to off when we start to make a left turn. It will also be reset to on every 4 seconds, which means you cannot make two left turns within 4 seconds. If left distance is smaller than 3 meters, the car should be driving in a straight line. By reading the distance to left and right, the car would drive in a line using PID control. In this demo, we only make left turns, but it is also adaptable to make right turns. And making a left turn has a higher priority than making a right turn. A single lap will take roughly 50 seconds. We designed several buttons on website. By switching on power and auto driving mode, the car will start moving by itself. If you want to drive manually, simply switch the auto driving mode to manual mode. We have 5 buttons for manual control. They are mapped into keyboard keys W, A, S, D, and C, so you can purely using keyboard for controlling. The video window on the right shows the real-time streaming video, and the blue block on top of the map indicates the current location. Although we have collected a lot of data and use MLKN algorithm, the localization is still a little bit jumpy. We think that's a problem of the beacon using XP. And also the video quality, we just slow down a little bit because the bandwidth of the router is limited. After switching the power to on, we can start controlling the car manually. Also, the direction buttons are mapped into our keyboard W, A, S, D, and C.
Don't be nervous.
Okay, let's get it back then. Go back.